So in 1.6, this was the homework that you had, was to take a look at this after our quiz. There's not a whole lot that's new. In 1.6, it's properties of exponents, but the exponents tend to be rational numbers, fractions, okay? Now, in most of these, there are a couple ways to work a problem. So let's look at this first one. 5 to the 5 halves times 5 to the 1 half, okay? When I see something like this, the exponents, when I combine them, they must be what to each other? What do I do with the exponents? I add them. So I'm going to work this problem two different ways. If I add those exponents, this is 5 to the 5 halves plus 1 half, okay? What is 5 halves plus 1 half? How many halves? That's 6 halves. This is 5 to the 6 halves. What's another word for 6 halves? 3. This is 5 cubed. What's 5 cubed? That is 125, okay? Now, another way to have done this problem, I could convert it to radicals. This is the, square root of 5 to the 5th. Let me sort of rewrite that where you can read it a little bit better. This is the square root of 5 to the 5th times the square root of 5, okay? And that is, did I do this right? Yes, square root of 5 to the 5th and square root of 5. So this is the square root of 5 to what power? 5 to the 6, okay? In square roots, under the radical, I like to organize everything as perfect what? Perfect squares. So this is the square root of 5 squared, 5 squared, 5 squared. What's the square root of 5 squared? 5. How many do I have? 3. So this is 125, okay? So there are multiple ways of getting to the answer in all of these, okay? You can go to radicals, you can stay with exponents. Either way, as long as you're obeying the properties that are there, you're going to be fine, okay? If I look at something like this, look at number 4, 9 to the 2/3 times 3 to the 2/3. Can I add those exponents? No, why not? Why can't I add the exponents? Yeah, I've got a 9 and a 3, but if they were both the same number, could I add the exponents? So what if I wrote this as 3 squared to the 2/3 times 3 to the 2/3? What's 3 squared to the 2/3? That's 3 to what power? That's 3 to the 4/3 and 3 to the 2/3. Well, I got to write it correctly. What do I do to the exponents now? I add them. This is 3 to what power? 3 to the 6/3. What's 6/3? Come on. 2. This answer is 9, okay? So there was a question from that corner of the room, can you do this with a calculator? You can do this without a calculator, guys. This is arithmetic, okay? You can certainly handle all of this. What about number 5? Can I combine those two? Why is it not 72 to the 1/6? I can't do that because these are not the same. What's 9 to the 1/2? What does that mean? Square root of 9. What's the square root of 9? 3. What's 8 to the 1/3 mean? Cube root of 8. What is that? 2. This is just 6, okay? So you should be very good at recognizing square root of 9, cube root of 8, okay? I have trouble with like the 243 and the 729. You don't have to get that far up in terms of memory, but you can certainly get there for these others. There was another one the last class wanted. Let me see if I can do that one here. Let's look at this one. Number 11. Okay, in number 11, what is being raised to the 1/4 power? 27, not negative 27, okay? The only thing being raised to the 1/4 is 27. There's a negative in front of it. What's being raised to the 4/3? everything that's in the parentheses, okay? So if I want to look at this, a couple ways of breaking this down. I can think of this as, this is negative 1 times 27. I can think of it this way, okay? The 27 is being raised, 27 to the 1/4 is being raised to the 4/3. The negative 1 is being raised to the 4/3, okay? So negative 1 to the 4/3 times 27 to the 1/4 times 4/3. So what does this mean? This means the cube root of what? Cube root of negative 1. What is the cube root of negative 1? Negative 1. What is negative 1 to the 4th power? 1. So this is just 1. What is 1/4 times 4/3? No? Well, it is 4/12, but easier. 4 over 4 is 1. This is just 27 to the 1/3, okay? When I look at this, 4 over 4 is 1. This is just 1/3. What's the cube root of 27? That's 3, okay? So this answer is just 3, okay? And I think some people got a little bit confused about the negative signs on here as well. Just keep in mind, this exponent only applies to this number. That negative is just simply there in front of it. But this exponent applies to the negative and that number, okay? So this was 1.6, just a few problems that you had to take a look at. What I want to do today in 1.7, there's really not any new concept. We're just continuing on simplifying radicals, working with exponents, okay? So just continuing on what we've been doing for the day here. So let's simplify a few of these. 4th root of 625 times x to the 12th. Okay, so I see 4th roots, which means I want everything under the radical to be arranged as perfect what? Perfect fourths. Okay, 625, if I don't recognize what it is, I just need to break it down. I know it's divisible by what? Divisible by, well, I want to start with small prime numbers. I know it's divisible by 5. That's 5 times 125. That's divisible by 5. And if I keep on going, I find that 625 is 5 to what power? 5 to the 4th. So I can write this as the 4th root of 5 to the 4th. And then how can I write x to the 12th? Yeah, x to the 4th, x to the 4th, x to the 4th. What's the 4th root of 5 to the 4th? 5. What's the 4th root of x to the 4th? X. How many do I have? 3. So the answer is what? 5x cubed. Okay? So again, we've done this on the last quiz, just making sure we keep this skill sharp for next Tuesday. Looking at the next one, I need to organize everything that I can as perfect what? Perfect cubes, okay? What about 6? Can it be organized as a perfect cube? No, I mean 1 is a perfect cube, 8 is a perfect cube, 6 is not. So this is going to be the cube root. I'm going to have to leave the 6. How will I write x to the 4th? It's just x cubed times x. How will I write y to the 9th? It's just y cubed, y cubed, y cubed. How will I write z to the 14th? Okay, so that's just z cubed, that's 9 of them, that's 12, and how many more do I need? 2 more, okay. What are all the perfect cubes under here? There's the x cubed, all of these y's, and all of these z's. So what's the cube root of x cubed? X. Cube root of y cubed. How many of them are there? There are 3 of those. Cube root of z cubed, and how many of those are there? 4. And then I'm left with the cube root of what? 6x z squared. Okay? So it's just, how do we organize the root being a cube root tells us how to organize everything. Now, what some people would do when they get to this 14th, the cube root of z to the 14th, you can just write that as the cube root of it might be more common. It's z cubed to the 4th. Okay, so you know that, okay, the cube root of z cubed, 4 of them come out, okay? I just prefer from a visual standpoint, just write it like this, and then I can visually see what stays under the radical, what comes out of the radical, okay? So this is a little bit more writing, but it's just organizing things so that you can go back and check your work. Square root of 49x to the 5th. What do I know the square root of automatically off the bat? 49 is 7. So this is 7 times the square root of x to the 5th. How will I rewrite x to the 5th? Yeah, I'm going to write this as x squared, x. That's 5 of them. So what's the square root of x squared? X. How many of those are there? Yeah, so this is 7x squared times the square root of x. Okay. Cube root of 16 times the cube root of 4. Okay. I can't really simplify the cube root of 4. 16 can simplify because it's 8 times 2, and I can get the cube root of 8. What am I going to do to get this as simple as I can? Yeah, multiply these together. So this is the cube root of 4 times 16. What's 4 times 16? Yeah. So this is the cube root of 64. Do I know the cube root of 64? Yeah, that's 4 times 4 times 4. So this answer is just 4. Okay. Now another way you could have done that is you could have said this is the cube root of 2 to the 4th times the cube root of 2 squared. So this is the cube root of 2 to the 6. That's the same thing as the cube root of 2 cubed times 2 cubed, which is, just one moment, 2 times 2, which is 4. Okay, there are multiple paths of getting to this answer. Yes, Jack?
What if you divided 64 by 2 and you got 2 cubed times squared?
If I divided 64 by 2 in this step,
Yes.
you can't do that. Right, but I can't do that. I can't change it. I can't just divide it by 2. I'm changing the problem. I need to take the cube root of 64, so I can't divide it by 2 without changing the problem. Okay? Let's look at the next one. Square root of 3 over the square root of 75. Okay, can I simplify the square root of 3? Okay, is 75 a perfect square? So if something is not a perfect square, then I ask myself, is it the factor of two things multiplied, one of which is a perfect square? What about 75? Can it be written as the product of something that's a perfect square? It's what? 3 times what? 25, right? So I can write this as the square root of 3 over the square root of 3 times 25. What's the square root of 25? 5. So this is square root of 3 over 5 square root of 3. I try not to say cancel out in this class, but what is the square root of 3 divided by the square root of 3? It's what? It's 1. Okay, so people get cancel happy, but square root of 3 over square root of 3 is just 1. This answer is what? 1/5. Okay, that is your answer there. Okay. Again, so these are things that some of these could have been on the quiz, some of these are a little bit more complicated, but the same concepts is what we're doing. Now we switch gears a little bit when we add and subtract. We can only add and subtract expressions with variables or square roots if the expressions are what? We can only add them what? if the variables are what? The same. Or I can only add something square root of 2 to something square root of 2. I can't add square root of 2 plus square root of 3. I can't do that. I can add square root of 2 plus square root of 2. So the radical, those expressions have to be the same. So here I have a to the fourth, b to the 2/3. So this is 15 apples plus 8 apples. The answer is what? Just 23. So this answer is 23, a to the fourth, b to the 2/3. The only way I can add those things together is because the a to the fourth and the b to the 2/3 are identical in both expressions. Okay? Now let's look at the next one. Are these expressions, can I add these together right away? Yeah, I can't say it's 10 minus 1 and 9. So now the chore becomes, if I simplify it, then can I add it together? Okay? Answer is not always yes, but I try to craft these problems where that is the case. So I need to simplify the fourth root of 5s to the 7th. So this is 10 times the fourth root of 5. How can I write s to the 7th to be simplified with fourth roots? S to the fourth, right? And then s to the what? Cubed, okay? That's the way I'm going to write s to the 7th, okay? Minus s. Now let's look at 80. Can I simplify 80? When I look at it, I know immediately 80 is divisible by what? By 2. It's 2 times 40. That's divisible by 2. Divisible by 2. Divisible by 2. Do I see 4 of anything? Yeah, there are 4 2s. So this is 80 is 2 to the 4th times 5, or 16 times 5. Okay, that gives me a perfect fourth. So I can write this next expression as 2 to the 4th times 5 s cubed. Okay. In the first radical, what is my perfect fourth? This s to the 4th. Over here, what is my perfect fourth? 2 to the 4th. Those can come outside the radical. So I'm going to have 10s times the fourth root of 5s cubed minus s times what? 2, and the fourth root of 5s cubed. So this is 10s fourth root of 5s cubed minus 2s times the fourth root of 5s cubed. And what's that answer going to be? How many? 8. So the answer is going to be 8s fourth root of 5s cubed. Okay. So this one, by simplifying the radicals, I see that I can actually combine by addition and subtraction because the expressions are equal. Okay. 6 times the fifth root of 5 plus 4 times, 6 times the cube root of 5 plus 4 times the cube root of 625. Can I add them together just like this? Is it 10? Can I add them together right off? No. I can only add them if what's under the radical is what? The same. Okay, the fifth root of 5, that's as far as that can go. But then I just look at 625, and if you don't memorize it, you do know it's divisible by 5. That's 5 times 125, which is 5 times 25, which is 5 times 5. So 625 is 5 to what power? 5 to the 4th. If I'm organizing this as perfect cubes, how can I write this? Yeah, 5 cubed times 5. So I've got 6 times the cube root of 5 plus 4 times the cube root of 5 cubed times 5. So what's the perfect cubed in this second radical? right there. So this simplifies to 6 times the cube root of 5 plus 4 times what comes out? The 5 comes out, and I'm left with the cube root of 5. So this is 6 cube root of 5 plus 20 cube root of 5. So can I add those together? Yeah, this is what? This is 26 times the cube root of 5. Okay, pretty easy, straightforward. It's not a Monday, but it feels like a Monday. Okay. An exponential Monday. How about that? Monday squared. So, okay, let's do one more, and we'll let you guys go. Not let you go, but let you start working on the homework. Um, Again, can I add these together? Not in this form, okay? I'm taking square roots. What's the easiest thing to take the square root of when you look at this right now? The 9. So this is 3x times the square root of x cubed minus 2 square root of x to the 5th. Because it's square roots, how can I rewrite this first radical? 3x times the square root of what? How am I going to rewrite x cubed? Yeah, x squared times x minus 2. How am I going to rewrite x to the 5th? X squared times what? X squared times x. Okay. So what's the perfect square in the first radical? X squared. And then I see perfect squares over here in the second radical. So what's the square root of x squared? X. So that comes out. So I get 3x squared times the square root of x minus, what's the square root of x squared? X. And I have 2 of them. So I get 2x squared times the square root of x. So what's 3x squared square root of x minus 2x squared square root of x? It's just 1x squared square root of x. So your answer is just x squared square root of x.